When you're putting large assemblies together that contain many similar parts, you can save time by using mating techniques such as smart mates and mate references to quickly position components. While many SolidWorks users are familiar with these concepts, few are familiar with the benefits of using named mate references. Before we take a look at named mate references, let me quickly review the concept of smart mates. A smart mate is a mate that SolidWorks can add automatically based on the geometry you select when creating the mate. Here, for example, I have two components open, an assembly with a single elbow component and a pipe component. I'll click and drag the pipe component into the assembly, being careful to click on a circular edge when I do this. As I move the pipe close to the elbow, you can see it snaps into place. If the preview indicates the part needs to be flipped, you can press the Tab key to switch the alignment condition. Remember, this is a geometry-based mate, so any corresponding piece of geometry, a circular edge in this case, is a potential target for the pipe component. Now keep in mind that nothing special has been done to either of these parts in order to achieve this smart mate behavior. Once the part is dropped into place, you can see in the Property Manager that two mates have been added, concentric and coincident. While this is helpful, notice the pipe component still has the freedom to rotate. If the component wasn't symmetric like this pipe is, this might leave you in need of another mate to prevent rotation. This is where a named mate reference can be helpful. I'll open the pipe component in its own window. I'll add a mate reference using the Insert Reference Geometry drop-down menu. The first entity I'll select is the inner diameter. By using this circular edge, this mate reference will now replicate the behavior we saw earlier, that snapping into place that created both a coincident and a concentric mate. To prevent the component from rotating, I need to add a secondary mate reference. For this one, I'll select the right reference plane and select the parallel mate type. To complete this mate reference, I'll name this set of mate references Pipe Mates and click OK. I'll save the part and return to the assembly. In order for the mate references I just created to have an effect, the corresponding component, the elbow in this case, must also have the same mate reference. In addition, the mate reference must have the same name. I'll open the elbow and add a mate reference identical to the one added to the pipe component. To make the component more versatile, I'll be sure to add the mate reference to both ends. Note that it's perfectly fine to have more than one mate reference with the same name. I'll save and close the elbow component, and tile my windows to make both the assembly and pipe component visible. This time, when I drag the pipe component into the assembly, notice I no longer have to worry about selecting the circular edge. I can click on any face, or even the part icon at the top of the Feature Manager tree, and drag the pipe into the assembly. And looking at the pipe mates in the Feature Manager tree, you can see that this time a parallel mate was added along with the coincident and concentric mates. This fully defines the component.